Component 3, upper 6 class questions. And we're on question 1. Surface area to volume ratio of an organism is related to its ability to exchange gases with the environment. Whew. Heat can be lost or gained through the body surface. And so on. Describe and explain. So describe and explain. There are 2 jobs there. The common adaptations of the gas exchange surfaces found in fish and mammals. So you know your properties of gas exchange surfaces, things like permeable, quite often moist, thin, large surface area, maintenance of a gradient. Here we need 3 of them, or maybe 3 marks, so maybe 2 of them, and example in fish and mammals. So, for example, thin, and why? To reduce diffusion distance. And then I could give e.g. alveolar wall is 1 cell thick. We could have moist here. I'm not going to really go on much about that. There's better answers than that. So a gas exchange surface quite often has a good blood supply, a rich blood supply. E.g. dense capillary network around alveoli or in the gills, and that will maintain concentration gradients for oxygen or CO2. And then finally, probably the one that nearly everybody got, large surface area. And I'm spelling out surface area, I'm not putting SA. So more area for diffusion. So e.g. folded surface of alveoli or lots of gill lamellae. So it's quite complicated, the actual marking system for that. You could, if you sort of given some adaptations and not really linked them, you could have 2 marks, or if you just given the adaptations and no link, 1 mark. But as many as you can. Here's a graph. Everybody got the general relationship. So the greater the mass, the greater the metabolic rate. There's only 1 mark, so we didn't really need to give any numbers. It's a directly proportional kind of relationship. Next part, 2 marks. Easy for the first one really, and then more difficult to get another answer. Why warm-blooded animals, which have a constant body temperature, have a higher metabolic rate? Lots of people here repeating this question. Warm-blooded animals have a constant body temperature and so have a higher metabolic rate because, and it's just a waste of ink. So the point that you might not have got to start with, the body temperature is not dependent on the environment. So it's just making the point is that they're going to have to do something, some homeostasis kind of a mechanism to maintain their body temperature. Probably the one that you did get was energy, e.g. if we put ATP is needed to maintain the body temperature. And that explains the higher metabolic rate now. So higher metabolic rates, higher rates of respiration. And it says why they have why would they want to have a higher metabolic rate? Why would they want to keep the temperature the same? So an example for optimum temperatures for enzymes and so on. So optimum temperatures for enzymes or reaction rates are higher, or reaction rates are higher. At least one of the two there. Here's an insect, and it describes the airflow, and quite a lot of this is just remembering stuff that from the core or component 3 AO1 stuff. Explain the advantage to the insect of closing the spiracles. This is to reduce water loss. We can't say prevent water loss, as there is going to be some water loss, and so you'd be not telling the truth there. I also thought of another answer. It's not on the mark scheme, but closing the spiracles at different times would enable a kind of one-way flow of air that it describes, which I thought was a sensible answer as well. Suggests the role of the air sacs. We don't necessarily know. You can't remember what the roles are, but it's wanting you to suggest. One trap that you might fall into is suggest that these are like little lungs or lung surface, or to increase surface area. But you know about the structure of the insect tracheal system, and you know how it gets gases to the muscles, so they're not little lungs. So apart from that, there must be some sort of store of air, or to help the ventilation in some way. That's what it's wanting. So just don't fall into the trap. So to store air or aid ventilation. Explain the advantage of an insect having a ventilation system. Now this is directly AO1. I remember this from when we did it. Why has anything got a ventilation system? And it's almost back to where we started with maintaining that concentration gradient. So maintain concentration gradient for gases. Or an example, to introduce oxygen rich air, get rid of CO2 rich air. So hopefully straightforward there. Here we have a typical diagram, and we are within the insect. You should recognise this. We've got muscle fibres, our mystery organelles X, which everybody knows are mitochondria. We've got tracheole, the end of the tracheal system, and it's all in pretty close contact. You will notice that this tracheole here is surrounded by cells. It's not actually the chitin itself. But the first question is, are chitins of the wall of the trachea, so further up this system, have similar chemical bonding and function as cellulose. Explain how the chemical bonding in chitin enables it to carry out its function. So again, this is really just AO1. It's giving you a reminder. You shouldn't even need this reminder about cellulose because you've done that in the core concepts. So it's a bit like cellulose, so we want things like, it's the beta glucose like, it's not quite beta glucose, like monomers, that form beta linkages. So beta glycosidic bonds. They're still 1,4 bonds, but they are where the monomers are flipped, rotated 180 degrees each monomer. So just go and look at your structure of cellulose. If we drew cellulose, we've got a glucose ring, chain of glucose rings, and the glycosidic bonds will be alternate at the top and the bottom. When this happens, we can get hydrogen bonding between the kind of hydroxyl groups and between adjacent chains, so cross-linking. So cross-links between chains. These form microfibrils. So they are hydrogen bonds, but we just want the bonds, cross-links between these chains, making microfibrils. And then explain how this carries out its function. So the function is strength or structure. Then the last part, identify organelles X and Y, and explain why they are found close to the tracheoles. So there's X. Why are they found close to the tracheoles? There. So why are they really close? So X or mitochondria. Let's say what they do. Just a bit of core concepts. So we've got aerobic respiration generating ATP for these muscles. Why are they close to the tracheole? Well, that's a short diffusion distance for oxygen. Pretty straightforward answer when we say it like that, but you did struggle a bit. So X in mitochondria or mitochondrion, here 1, we're going to say aerobic respiration and requiring oxygen to make ATP, and for example, the end of the tracheole is the site of gas exchange. It doesn't say this in mark scheme, but the short diffusion distance. I know we've already said it early on. So short diffusion distance for oxygen, for example. So we don't need to repeat the question. We don't need to give long flowing sentences. We just need to get these facts out in an understandable way for those 3 marks. So you should really have got quite a high score, 15.